Okay, this is the chapter review for chapter 1 from the Math 2102 book. So anything that I'm about to say can be useful for any math student, but if you're in this book, what I'm talking about is what you have to know from chapter 1. And if you don't understand the things that I'm showing you, if you don't feel comfortable enough with it yet, it means you need more time in chapter 1. Okay, so what's chapter 1 about? It's about imperial system and metric system conversions. Metric, often abbreviated SI, which means Standard International. Conversions are when you convert one to the other, like converting 5 inches into centimeters. How do we do that? We have to do this thing a lot. And in real life, of course, we can use Google. You go into Google and you write 5 inches, and before you even finish the word inches, autocomplete will suggest into centimeters, and you choose that, and it immediately converts it for you. It's very useful. But for a student who is studying a math course, you're not going to be allowed to use Google while you're doing your final exam. You have to be able to do these things yourself and not rely on technology all the time. So conversions are simple little bits of math, but the thing that makes this a whole chapter is the fact that there are so many of them. Let's talk about that. For instance, in length, we have the yard. I won't write numbers, I'll just say we have the yard, and we want to convert that sometimes into meters. Sure, but we could also convert yard into centimeters, and it's a different conversion. Slightly different, yes, it is a slight difference. Yard can be converted into millimeters, into kilometers, and there are actually many more. And then we're only talking about yards so far. What about foot? We can convert feet into meters, feet into centimeters, etc., etc. So when you think of all the possible combinations, you can come up with many just from length. And length isn't the only thing that you measure in using the imperial and metric systems. So let's do some conversions as an example. I'm not doing all the conversions. This video would be too long if I did that. But for instance, a conversion factor is a pair of numbers that form a ratio between the two things we're trying to convert, which we use to figure out the conversion that we need. So 1 inch, for instance, is equal to 2.54 centimeters. We use this conversion factor, and there are different ways that we can do it. To convert, for instance, to convert 10 inches into centimeters. Let's do this 3 different ways. One way we can do it is by multiplying. 10 times 2.54 will give us the correct answer. So whenever it's inches that you have and centimeters that you need, if you know this conversion factor, you're just multiplying by 2.54, and that is quite easy. If it's going in the other direction, you could divide by 2.54. Let's see if that works. Well, it's pretty easy to see if it works. 25.4 divided by 2.54 is equal to 10. Yes, it worked. So with multiplication and division, you can do a lot of conversion factors. Just don't get them mixed up. Don't divide by 2.54 when you were trying to convert inches into centimeters. You're doing your operation in the wrong direction. Another way of showing this is with a proportion. This is my favorite way because students need to understand proportion. So if you practice proportion a lot whenever you do conversions, it helps you to understand it, and it helps you understand the language that goes with the proportion. 1 inch is equal to 2.54 centimeters, so I can call that a ratio, because it is a ratio, put an equal sign, and then put 10 inches here. This is going to work so long as I put the 10 and the 1, either both on the top or both on the bottom. They have to be together. And then putting x in the last remaining place, I cross multiply and I solve. What does that mean? 1 times x equals 10 times 2.54. Yes, it means I'm multiplying. So this is a big shortcut for someone who's doing this. But shortcuts are good when you are really understanding the situation, but when you're confused, like when you're dealing with weird numbers with weird decimals, maybe it's better to show the ratio and the proportion and do it this way because it helps you to remember, for instance, this time I multiply and I don't divide. So we have our answer, and of course it's the same answer. A third way of doing it is with an algebraic model. Okay, that's going to be really annoying to some of my students when they see this video because algebraic modeling was the topic of the previous book, Math 2101. And those students might be really sick of algebraic models by the time they get to chapter 1 of this book. But you can do this with an algebraic model, and it's a good example of how any operation like a multiplication can be easily turned into an algebraic model. What does that mean? It means I'm saying x is number of inches, so I'm defining a variable. Y is number of centimeters. And my model, my equation, is going to be y equals 2.54x. And then I plug the 10 inches from the question in here. Y equals 2.54 times 10. There we are doing that same multiplication again. So of course we're getting the same answer again. Regardless of which method you like to use to do your conversion, make sure that you show how you got the value. Do not say on a math exam, just plunk down 25.4 centimeters. No matter how correct that is, as the teacher who's correcting it, I have to play dumb and say, what 25.4 centimeters? How'd you get that? That's why we have to show our work when we do math exams. Okay, now I'm not doing all of the examples because there are so many different examples, but that's enough examples so that you see what we're in for when we are converting between imperial and metric. So let's talk about the other types of conversion, the other types of measurement that we do. We have length. We've covered length pretty good. What other ones are there? There is capacity. Volume. What are the interesting things to bring up when we talk about volume? Well, volume can involve things like the centimeter cubed or the meter cubed, but it can also involve things like the liter or the milliliter. And one of the most useful things in all of math conversion, in the whole world of math conversion, is the fact that 1 centimeter cubed happens to be equal exactly to 1 milliliter. This really helps because one of the most common ways in which students actually encounter this in all the different math books I teach is when they're given a shape, a three-dimensional shape, with measurements in centimeters, and they're asked to give their final answer in liters. So they have to convert between this cubic distance type of capacity unit into the liter type of unit. And the easiest way is to get whatever you have in centimeters cubed, and then it's a one-to-one. That means you have that same number of milliliters, and then you can start doing your conversion to give liters or deciliters or whatever the question might ask for. Mass. So for mass, we have in imperial the pound, the ounce. In metric, we have the gram, the kilogram, and there are conversion factors that go with these. There are conversion factors besides this easy one that go with these. You can get the conversion factors easily from the internet or from a textbook or from Google. You can get Google to actually do the conversion for you, but you want to be able to do it yourself. The math that's involved is the math that I illustrated with my little 10-inch to centimeters example that I did 3 times. You're doing that same type of math operation over and over and over again for all of these different situations. What else? Temperature. Degrees Fahrenheit and degrees Celsius, converting them back and forth. What is there to say about this? Well, one thing is that there is a linear relationship between the two, which means that you can solve question where they give you Fahrenheit and ask you for Celsius, or the other way around with a simple formula. There are two versions of the formula that I'll write down. Degrees Celsius equals 5/9 degrees Fahrenheit minus 32. Or degrees Fahrenheit equals 9/5 degrees Celsius plus 32. It's really the same formula, it's really the same linear equation, just with a different variable isolated on the left. It's interesting how little I use this, because I deal with both degrees Celsius and degrees Fahrenheit all the time. For instance, in Canada, you will usually always be talking about Celsius temperatures, and then you go to your oven and the little dial is in Fahrenheit. And that can be confusing. But we adapt to it, because often instructions for cooking things are given with both degrees Fahrenheit or degrees Celsius, or they're just given in Fahrenheit, but that's what my oven has, so it's no problem. One of the things that I do like to use is the fact that I remember 3 conversions between Celsius and Fahrenheit. One is that 212 degrees Fahrenheit is equal to 100 degrees Celsius, and I know that because that's the boiling point of water. And 32 degrees Fahrenheit is equal to 0 degrees Celsius, because that's the freezing point of water. And here's one that a lot of people don't know. Minus 40 degrees Fahrenheit happens to be equal to exactly minus 40 degrees Celsius. So in the two scales, that's where they happen to have the same number. Now, writing the conversion factor on the memory aid isn't going to help you very much, but writing an example of you using it on your memory aid might help quite a lot, especially if there are any that you find more tricky than the others. Those would be good examples to have on the memory aid. That is my review of Chapter 1 from Math 2102. And remember, if there's anything that I've been talking about during this video that you don't understand or not clear on, then it means you need more time with Chapter 1 and you need to maybe ask a few questions of your teacher.